Hello, my name is Ashley Goodnight, and this is my Lab 3 report for Physics 2212. Let's get into our introduction. The purpose of this lab is to measure the distance dependence of the magnetic field due to a small magnet and compare the observed results to the theoretical values. We care about this experiment because it allows us to practice key physics concepts, including Biot-Savard's law, and to gain familiarity with the GlowScript modeling software. In the end, I successfully used GlowScript to model the theoretical values of the distance dependence, which were predicted using the on-axis and off-axis simplifications of the Biot-Savard law. Here are a couple screenshots of my raw measurements. I will reference and display these values later on. Now, let's move on to the general observations I had while taking these measurements. We were asked to answer what happens to the value of the B field in the x direction as the magnometer moves closer to the magnet. First, assuming you were zeroing out the x direction by accounting for B Earth, the magnometer will read close to 0 when the magnet is far away. This leads into my second observation, which is that as you move the magnet closer, the magnitude of the magnetic field in the x direction will increase. Now, before getting into the code, I had to calculate mu, the magnetic dipole moment. In order to do this, I followed these steps. I solved for the k value using my graph. Next, I set the two equations for the magnetic field of a bar and a dipole equal to each other. Finally, I set the r value equal to 1 in order to solve for mu. Next, I will cover the changes I made to the starter sample code provided. First, I wrote this function for the magnetic field using the equation given on the lab sheet. Next, I programmed some initial positions for the observation locations. Next, I had to write the code for the arrows representing the magnetic field at these observation locations. Note, I am only displaying 2 of the 6 examples since the others followed the same process. Finally, I calculated the magnetic field 45 degrees off-axis, where I needed to plug in my value for dperp, where the absolute magnitude of the B field was equal to 100 microtesla. Let's take a look at these results. Here is what my GlowScript produced. Note that this view uses a B scale of 5,000 from an observation distance of 0.3. These, of course, were arbitrarily decided by me. As you can see, there are printed values at the bottom, so let's take a look at those. My GlowScript code calculated a theoretical 45 degrees off-axis measurement of 9.59 microtesla when I only observed a value of 8.89 microtesla. This is pretty close in my opinion, and there are a couple good reasons it's off. First, I conducted all measurements using a standard ruler by myself, which implicitly has error. Next, my environment could have affected my magnetic field readings. I did my experiment outside on the pavement, which had an initial value of 50 microtesla instead of the ideal 49 microtesla. Finally, let's move on to our conclusion questions. The first question asks, what would happen if I just laid my meter stick at some intermediate angle with respect to the Earth's magnetic field? Well, if I hadn't oriented my experiment to compensate for magnetic north, I would have had to go back and correct my measurements in all 3 directions, instead of just in the y and z planes. On to the second question. What would happen if I were to stick 2 identical magnets together end to end? Well, if I were to stick 2 identical magnets together, I would expect them to be stronger than one magnet, but not quite double the original value. This is because the magnet at the back will be slightly further away from the observation point, and its effect is slightly lessened. Thank you for watching. If you would like to see my GlowScript code in action for yourself, the link is in the description of the video.